The next part that we're going to talk about is you can determine the degree and roots of each polynomial, okay? The degree is based off of the number of factors that you have, okay? Your degree is based off of your number of factors. So in the corner, you're going to write number of factors equals your degree. We flip the book. So your number of factors equals your degree. A polynomial of degree n has at most n roots. So if I am a 5th degree polynomial, I can have up to 5 roots, right? If I am a 4th degree, I can have up to 4 roots. Do I have to have 4? No, but I can have up to. Does that make sense? Okay, so starting off, right here we have f of x equals x minus 2 times x plus 3. So there's 2 factors, which means that my degree, oh, my pen did something weird. So we have 2 factors, which means that this is a 2nd degree. Do we get that? Yeah. There are 2 factors. Factors are things that are being multiplied together, right? Okay, then it says, what are the roots? Your roots mean that you're taking your factors and setting them equal to 0. If I set x minus 2 equal to 0 and x plus 3 equal to 0, what does x equal? 2 and negative 3. That's the answer. It's a 2nd degree polynomial, and its roots are x equals 2 and x equals negative 3. Because negative 3 plus positive 3 equals 0. Okay. All right, so let's do this one. This one is not an expanded form. This actually says you have x minus 4 times x minus 4. How many factors do I have? 3. So we have 3 factors. So what is the degree of this polynomial? It is a 3rd degree polynomial. Okay. What are your roots? Your roots is if I'd set each factor equal to 0, so each variable factor equal to 0. Well, x equals 0 is just going to be 0. And x minus 4 equals 0 is going to be what? 4. How do we feel?
I'm sorry.
Yes.
Okay.
Still doable?
Yeah.
All right. So this one is not an expanded. So this really means that I have negative x minus 2 times x minus 2 times x minus 2. How many factors do I have? 3. 3 factors. Does that negative have a variable? No. So it's a numerical factor, not a variable factor. Okay. So I have 3 factors, which means that this is a 3rd degree. Even though it's a 3rd degree, are these going to be different? No, they're going to be the same because it's all x minus 2. So x equals 2. Good job. All right, this guy. Do we need to expand? Expand. What is that? Expand. Yes. So we have how many? 4. Good job. Because that means we actually have how many x's? 2. How many x minus 4? 2. So we have 4 factors, which means that this is a 4th degree. Okay. If I was to take x and set it equal to 0, x would equal 0, right? And then if I take x minus 4 and set it equal to 0, what would x have to be? 4. How do you feel about finding the degree and the roots? Yeah? No? Maybe so? Was it terrible? Okay, it's going to come together over there in a second. All right, so our roots are important. So notice how that up to thing, we're going to talk about what that means. So we have what's called multiplicity. We have multiples of this, right? We have multiples of this, multiples of this, multiples of this. This is called multiplicity, okay? So graphs of polynomial functions are smooth, continuous. They have no breaks, no gaps, or holes or sharp turns, okay? So there's no discontinuity, which means that the domain is all real numbers. It goes forever from negative infinity to positive infinity, right? Because I have no gaps, no holes, no asymptotes, okay? The end behavior, we already discussed our end behavior. Our end behavior depends on the degree and our leading coefficient, right? Whether our degree is odd or even, and if our leading coefficient is positive or negative. Agreed? Okay. Now, the multiplicity. Your multiplicity is telling you how it acts around the root, okay? A single root multiplicity is going to cross the x-axis. Okay, so what that means is that when we had the factors, what did we have? What was number 9? X equals, what was it? 2 and -3, right? These were single. Did they double? Were there triples? No. They're called single roots. So what happens is that, was it -3? My pen won't let me write. Pen. At -3 and +2, the graph is just going to go through them, right? It just crosses. So it crosses at single roots. So we had x plus 3 and we had x minus 2. It just crosses. Okay. Now, when you have a double root, I like to say it kisses, but it's called tangent. Okay. It is tangent to the x-axis. So we are tangent to the x-axis. Okay. I like to say it kisses the x-axis. Okay. So when we're looking at the examples at the top, that would be our, let's do x times x minus 4. So we had x times x minus 4 squared, right? So that tells me at 4, so at 0, I'm single. At 4 over here, so I'm going to cross. But at 4, I'm going to touch. I'm going to kiss the line and bounce back. I do not cross the x-axis. I'm going to, oh, hey, peck, and go. Okay. And then last, a triple root. A triple root is weird. It does like a little dance around it. It flattens out. So it flattens, but it's really hard to see it.
Does this flattens?
I think so. It flattens a word, right? Okay.
Yeah.
Flattens? Flattens? That's why I teach math. X-axis. It flattens around the x-axis. So which one was a cube? Was that number 11? 11, it said negative x minus what? 2? Example 11 said negative x minus 2 cubed.
Yeah.
So at 2, what's happening is that my graph, it's going to go like it. I can never draw it, guys. I suck at drawing flattens. Hold on. I got to try it again. I suck at drawing. It is not my expertise. I apologize. Maybe if I make it bigger. I'm going to try again. It flattens. Oh, I still didn't make it through. So it's going to start flattening out, and then it flattens, and then it curves back out. So it's going to flatten and then curve its way out. But I'm really horrible at drawing the flatten. I repeat again, I'm horrible. Yeah, that looks better. Yours look better than mine, hopefully. Okay, so it's going to flatten. So a single root. We're crossing the x-axis, we're minding our own business. Boop, boop, boop. Just, rolling through. Double root. Oh, I like you. I'm going to stay around you a little longer, okay? It's going to touch it and then go, all right? And if it's a triple root, it's going to slow down and flatten out around it, and then it's going to continue its curve after it's moved away from it. Very carefully. She did really good. I'm horrible at drawing it. Maybe I need to focus on like at the mark. I have no clue why I've been horrible. So they look like this. Oh, kind of. Oh, no. Let me just make the graph do it. Let's just. Let me. So we're going to do x. What was it? -2 to the third. To the third. I forgot my negative in front. Okay, let's see.
Yeah, no, it's not. Wait. Are there any, like,
Okay, do y'all see how it kind of flattens around it? So it doesn't just ignore it. It goes. In my mind, I know it's doing it. But in my drawings, it's another story. Okay. All right, so on your assignment, you're gonna have to be able to, it's a combination of using your factoring skills, paying attention to the end behavior. So we're gonna talk about drawing. But you don't have to draw, you just have to match the drawing. Does that make sense? So you don't have to worry about trying to be perfect on the bottom ones. So we're gonna go through an example of putting it together. Bless you. All right, so here, the first thing you want to do is make sure that the polynomial is factored, okay? So you want to make sure that it's fully factored. After that, you want to find the x-intercept, and you find the x-intercept by setting each factor equal to 0, okay? Then you're going to find your y-intercept. To find your y-intercept, you're going to just evaluate f of 0, which means that wherever x is, I plug in a 0, okay? And then you're going to sketch the graph using the multiplicity, okay? So here, when we look at this graph, is it fully factored? Yes, I don't need to do anything else. Factoring is done. So step 1, done. Step 2 is to find the x-intercept. So to step 2, I'm going to take each factor and set it equal to 0. So we know that one of our x's is at 0. Where's our other ones? 1 and -4. So we know we're at 0, 1, and -4. Okay. If you want to go ahead and graph those, you can, or you can just wait. Okay. Step 3 is to evaluate f of 0. F of 0 means everywhere that there's a 0, I'm going to plug in 0, which so happens to be what here? There's 3 of them, and it's just going to equal what? 0, which makes sense because I'm at the origin. And now we're going to sketch. So you're going to sketch everything you have. I have my x-intercept here. I'm going to put -4 here. I'm going to put +1 here. Close enough. And now I'm going to pay attention to my, oh, it's supposed to be sketch graph using multiplicity and end behavior. Dang it. End behavior. Sorry, guys. I forgot a very critical part. So your end behavior here would be, if I was to multiply this out, my degree would be what? Well, it's a third degree, and all of my x's are positive. It would be x, x, x. So my leading coefficient, would it be negative or positive? Positive. So I'm an odd degree positive, which tells me that I have to end where? Where's my right? I have to end up on the positive and start in the negative. So when I'm drawing this, it's going to look like this. And there's my sketch. Okay, degree, third, LC is, my leading coefficient is positive, which tells me I have to start positive, but because it's odd, I'm going to have to, then I'm going to end positive, but start negative. Remember opposite Bob? It's like this. Did I started negative, but I ended positively. Bob is doing this. My leading coefficient was, if I had x times x times x, what is it gonna produce? A positive 1, right? And my degree was 3 because how many factors did I have? 3. Okay, now it's easy when it's already factored for us, right? But what if it's not factored? Then you gotta factor it, which is why we spent 2 weeks learning how to factor, right? So, oh no, this isn't factored. I quit. That's what some of y'all would say. That's what some of you would say, but that's okay. We should always start with our GCF. What is the GCF here? X, 1x, right? So I can take out 1x from everybody, which is going to equal x times x squared minus 4x plus 4. Okay, this is a simple factor. So I'm asking myself what multiplies to give me 4, but adds to give me negative 4. So what two numbers multiply to give me 4, but add to give me negative 4? What kind of 2's though? Negative 2's. So my factors are x times x minus 2 times x minus 2, which equals x times x minus 2 squared. Okay, that's why step 1 is to make sure you are fully what? Factored. So step 1 is now good to go. Okay, step 2 tells me to do what?
Find x at 0.
So step 2 is I'm going to take each factor and set it equal to 0. So we have x equals 0 and we have x equal 2. Perfect. Okay, step 3 is fairly easy. If I plug 0 into everything, what's going to equal 0? Okay, if your x-intercept is 0, guess what your y-intercept has to be? 0. Okay. All right, step 4 is our multiplicity. So notice here at x equals 2, it has a double multiplicity. Because remember this guy right here? It was squared. So it has a double multiplicity. What did we say a double meant is going to happen? It's going to kiss the line. It has to kiss it. It's going to touch, right? Okay. So we're dealing with the multiplicity and then our end behavior. Looking here, we have an odd positive. So what is our end behavior doing? So on the right side, what is Bob's hand doing? On the right? On the left, he's going down, but on the right, he is going up. So the positive tells me my right, the odd tells me my left. All right, let's draw Bob. Let's draw. So we have x equals 0, x equals 2, and I'm going to start from the left, cross. I'm going to come to the 2, and I have to do what at the 2? Kiss and go up. I do not cross it because it is a double multiplicity, not a cross. It's a kiss. Yep. Beautiful. Okay, so let's look at your assignment. We have more practice problems, but we'll pick them up tomorrow. I want you to look at your assignment quickly. All right, so here you have your graphs, right? You don't have to do the graphs, you just have to match them, right? Following the same steps we did and just checking. So easy things to do is to factor, right? So we're going to factor them, look for the zeros, pay attention to the end behavior. You can probably eliminate a couple just by the end behavior and the degree, right? Okay. So that's what you're doing. Okay. Tomorrow we're going to learn about max and, well, hopefully we'll get there. But do we need to see more examples of the factoring? Or are we okay? I have 2 more examples that we can do if you need it.
first one is X. So you're looking for.
Uh-huh.